Assalamu alaikum everyone. It's Mr. Fahad here. I'll be covering the grade 12 math advanced curriculum. So we will focus on the concepts for each of the lessons. This is the first video in this channel. I hope you find it useful. So with the first lesson, which is a brief preview of calculus, we will focus on tangent lines and length of a curve. This is again Unit 2, Limits and Continuity. The objectives for today's lesson is to estimate the slope for a given function at a given point using tables, and then we will estimate the arc length for a given function. Alright, so we'll start with the basics. You have the slope of a straight line as y2 minus y1 over x2 minus x1. You studied this before. And the slope of the secant line is the same formula. Now, the slope of the secant line represents the average rate of change of the function. And you can see here in this graph, if you took the secant line, the orange one, then you will get a decent approximation for the slope at a given point in between. And as you approach this point, then the approximation will be more accurate. Of course, the exact slope of the point at the curve is the slope of the tangent line. But in this lesson, we will only use the method of approximation. Here's an example. Estimate the slope of this function at this point. So you can see the first step here to do is substituting the point in the function to get the y coordinate for the point. We have the point here at 1 and 2. And now, in order to approximate the slope at this point, we will pick points to the right, to the left, near this point, and then we will try to find the slope of the secant line. So we choose sequence of points near 1 and 2 and compute the slope of the secant joining each point with 1 and 2. So to the right, we will take 2 and 5 and then try to find the slope of this secant line between these 2 points. The slope for this line will be y2 minus y1 over x2 minus x1. You can see the points here. Applying the formula, the slope is 3. And then we'll get closer to the point. We'll pick 1 and 1, substitute in the formula using your calculator, 1 and 1, and you'll get 2.21. Now, between 1 and 2 and this point, I can again find the slope of the secant line. So you can see that this approximation is more accurate. Now let's get even closer with 1.01 and substituting in the formula, I'll get the y coordinate, and then the slope is approaching 2, as we can see from the right side. Now we will do the same thing from the left side, and we'll start with a point to the left of 1. Let's start with 0. So between 1 and 2 and 0 and 1, we can find the slope of the secant line, y2 minus y1 over x2 minus x1, and this will be 1. And now we will get closer to the point 1 and 2. Let's use 0.9 again. We are approaching to the point 1 from the left, and applying the slope formula, it will be 1.9, and even closer at 0.99, this will be 1.99. So you can see from the left side also we are approaching 2. So as the point gets closer to 1 and 2, the slope of the secant line gets closer to 2. And the estimation of the slope at the point x equals 1 is 2. That's it. All right, let's try another example. And this example, I encourage you to pause the video, try to do it on your own. Okay, I hope you did so. So let's jump into the solution. We have the desired point here as 0, so I need to find the y coordinate at this point. And substituting in the function, sine of 0 is 0. So I need to take point to the right and then get closer, find the slope of the secant line at each point, and then do the same from the left side. All right, so from the right side, we'll pick the point 1 and sine of 1. Now, between 1 and sine of 1 and 0, I need to find the slope. Applying in the formula for the slope, this will be the value of the secant line slope. Let's get even closer with 0.1 and sine of 0.1. Applying on the formula, again, just use your calculator, and you can see we are approaching 1. So the slope from the right side is indicating that the slope at 0 equals 1. From the left side, we'll use the point -1 and sine of -1, and then find the secant line slope, which is 0.8 approximately, and then move closer to the point at -0.1, sine of -0.1. You can see that the slope is approaching 1. That's it. So the slope of the secant line is getting closer to 1. Therefore, we can say that the slope of the curve at 0 is 1. All right. Moving to the second part of the lesson, the arc length of a function on a given interval can be approximated by finding linear distance between points that have evenly spaced coordinates. So for example, we have this curve and we want to find the arc length or the length of the curve. Then we will divide this curve into intervals, evenly spaced intervals, and then we will find the distance between the endpoints for the straight line or the line segment between these endpoints. All right, so we will just use the formula for the distance, and we will be finding the sum of the length, and then the more line segments we use, the better, because it will give us a decent approximation for the arc length. Now, the question will be deciding the number of line segments usually. Here's a question. Estimate the length of the curve f of x at this interval. Now, first, I need to take the endpoints, and then the question provides that the number of line segments here is 4. This means we need to find the length of the interval and then divide it over 4. So b minus a, again, b is 2, minus -2, which is 4 over 4, and this gives us an interval of length 1. So each time, starting from a, or the initial endpoint, I'm going to add 1. So this gives -1, and then you add 1 each time. And you can see here in this graph, I have the points, and then I substituted each point in the function to give the y coordinate. What I'm going to do now is calculate the distance for each one of these intervals. Okay? Let's start with the first one, from -2 and 5 till -1 and 2, and just apply the formula for the distance for each one of these line segments. Here's the length for the first one. You can just use your calculator to do this calculation. And second one, third, and fourth. Again, 4 line segments. Now the length of the curve can be approximated by adding all of the 4 line segments, right? Just add the length of these 4, and this gives decent approximation for the curve length. That's it. Another question, I encourage you to pause the video, try to solve the question on your own. Okay, estimate the length of the curve at this interval. So the first thing to do here is find the length, and then the question provides that we need to do 4 line segments. So you take the length of the interval divided over 4, and this gives the sub-interval length, which is half. So starting from the initial point, you gonna add half each time. So you can see here we have 4 line segments, and I need to calculate the distance between each 2 consecutive endpoints. Again, just like we did before in the previous example, just take the points, substitute using the distance formula, use your calculator, and now we will add the lengths of these line segments. And this gives me a decent approximation for the length of the curve. Well, that's it for today. Thank you so much for watching.